Good day, everyone. Today we are talking about functions. Let's get into it. All right. In this presentation, we're going to just mainly understand graphs and talk about the details of it. We're not going to talk about real life situations yet, but we will, but not now. And we're mainly going to talk about the characteristics of these functions in details. All right. So look. Don't forget, I need 5 tutoring sessions done by the end of this week. If you have not made it to 5, you may want to try to get some work in because once we're done, that's that. I know ANET has dropped a lot of you guys' grades down because I told you guys prior to ANET to take it seriously. A nice number of you guys did, but most did not. So hence the grade decrease. So once you get to 5 tutoring sessions, what I can do, I could create a quiz, and that quiz grade could help deal with that test of ANET. But that's only if you attended 5 tutoring sessions. If you have not attended 5, I can't give you that privilege. But when you do get to 5, then we should see about it. Alright? So next week, I am testing you guys. Just letting you know. I need to see where you at. So the little ACT pre-Algebra 1 topics we've been dealing with, such as percentages, graphs in particular, and talking about the functions that we are going to get into today, and rational exponents. And I may throw in some trig stuff too. So the reason why I'm going to throw in old stuff that I have done, because you need to know it. If you don't hear it, you're going to forget it. And that's what happened to many of you guys, because you guys don't see the math, you forget it. So if you don't use it, you lose it. All right. Your last ACT registration is March 5th. Get that done by March 5th. If you need help, just see me on my off period with a pass, and I can help you. Otherwise, there's a new rule going on that unless you got a pass, I can't interact with you. So see me for the vouchers. And remember, the minimum score of 18 is required. So that means you gotta get 24 questions out of 60 correct. You must present proof of your ACT score. So once you take it, you must show me that you got the 18. And once you get an 18, you are exempt from everything but classwork and ANET, like I've been telling you. And so far, only one student has done that. This Algebra 2 course is going to be even more difficult. I need for you guys to really home in on the ACT. We've been covering, the pre-algebra and the algebra 1 aspects of it. So please, 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 let's do better. All right. Let's talk about Black History. The reason why I'm canceling Black History project because I don't really trust you guys with doing it properly. So I'm going to include it into my presentations. So you will need to know her. So be aware this is something that's going to be on test. So please know who she is. Dr. Gladys May West. C certified the precise definition of mathematics by modern patterns and environment. And she did that by using geometry to create the GPS on your phones. I know You guys, so I don't care, blah, 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 blah. But this is a fine example of how mathematics is used, you know, in real life. She used her geometry skills to create their GPS system using, that we use on the phone. Had it not been for her invention, we would still be using maps. Like maps is like sheets of paper to know how to get to places. And like I told you guys before, GPS did come out to the 2000s. And I was about almost a teenager at that time, so just saying, know about her. Also, know about him, Mr. Guillermo Gonzalez Camarena. Know about Mr. Camarena. You need to know about him because without him, we would not have the screens, the color screens that are on our phones that we see. Every screen we look at has color. It's because of him. And he did that by using his algebra and geometry skills to create the color screens. So you guys, please, 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 please take the time to know this. All right. So function characteristics. So this will get boring, but I already covered this in class. This is just for those who need it. And also, I already made a video talking about the parent functions some time ago. So I will be posting that video for you guys to look at as well. All right. So we know that the function of y equals x. We know this is y is the dependent variable and x is the independent variable. So remember, you try to make your money. And again, I'm doing this with my thing on my laptop, so it's a little hard for me to do. But like I said, be grateful that I'm even doing this. Your money equals your time you put into it. That's the best I could do. So again, a function is just pretty much what you've been doing, what we've been doing so far with the plotting points, drawing the graphs, all this, all that. Again, you guys have to know what's up. Gotta take it to a level. So this f of x equals y. This substitutes the y. This f of x part becomes y. This f of x becomes the y. This f of x becomes the y. So when you have tables like this, you notice that y no longer exists, it's f of x. So when you go to decimals, you're going to see f of x. Get that situated, all right? So know all that. All right. So you guys, a function has 5 important parts. 5 parts. 3 of these are very easy to deal with. 2 of these are a little bit more detailed. For sure on the test, you must definitely know these 5 parts. Alright, so the input is your value chosen. So your input, if you want to be elementary about it, think about x. Your relationship is the operation you do to get to the output, which is your answer, which is your y value. Alright guys, it must work for every possible input value. So that means that it has to work for every x. And it has one relationship for each input value. So this is an example of what I'm talking about. So your input is these values that we've chosen, which is your x, which is right there. Your relationship is your operations you do. Like here, this is square, right? So 0 squared becomes 0, which is your output. 1 squared becomes 1. 2 squared becomes 4, and 4 is your output. Again, your relationship is the operations you do. So you may want to recall this, like know how to recall it. Now I know you guys are going to leave for Mardi Gras break, but please y'all, be careful. Do not let the bon temps roulette too hard, because you do that, you may fail. So the correct way of saying that, don't laissez les bon temps rouler. Don't do it. Don't do it too hard, because of course I gotta test your skill. Remember, Algebra 2 is not about turning in worksheets after worksheets or whatnot. That's not gonna be the case. If you don't have the skill behind it, it's not gonna work. Alright, so here, you may need to know the precise definition of function. Alright, a precise definition of function. So this is more the grown-up version of what a function is. Instead of saying input output, now you gotta give me the more mature version of it. A function relates to each element of a set with exactly one element of another set, possible the same set. So again, input output, that's more of the kiddie term of it. But now we gotta talk about the grown version of it. Again, a function relates each element of a set is with exactly one element of another set. And here are the examples. So these little dots are your elements of X. But you notice that every element of the X goes to an element of Y. But you notice that there are some Y's that don't have X's going to them. And that's okay. The important thing is that every element of X goes to every element of Y. So those Y values could hang. Alright, so here's an example that you could think of to understand elements and sets. So, like I have told you in the classroom, you guys are the elements of my classroom, which is the set. And then if we want to, myself, you, and everybody who works there are elements. And then the set is that is a true Mahai. So I gave you two examples on your test. I may ask you for two unique examples. So you got to take the examples that I gave you and learn how to come up with two more of your very own. Alright, so let's look at this example. So the elements are the numbers of X, right? Which is the input, and the Y is the output, right? So we look through this, we notice that 3 F4 is not being used. And then we know that 5 is going to 3 different Y's. You cannot have that. You can never, ever, forever, ever, 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 ever have that in a function. For something to be a function, it has to have a relationship, meaning that every x has to go to a single y. All right? Every x has to go to a single y. Like 5, because of that 5 again is going to 3 different y's. You can't have that. All right? Now, you're going to see the converse of the y's going to a single x, and you're going to see how that's going to work out. All right? Are we good with this so far? I hope so. So, you really need to worry about injective. So, injective means that every x goes to 1, 1. So, it's going to be 1, 2, 1. So, 1x, 1y. A bijective means that you have an x going to y, that just means that y goes to x. So that means that the elements could flip around. And when that happens, we usually call this the inverse. All right. So here, again, this is a function because you notice how this single y right here, this y, this single y has 2 different x's going to it. That is okay for y to do. However, x cannot have this going on. Again, it's okay for this element of y having multiple x's, but you cannot have it the opposite way, meaning that you cannot have a single x going to multiple y's. All right. So if you need to, just run back to the previous example I have, and compare that to this, and you see what I'm talking about. Again, every x has to go to a y. You know, and do not forget that it has to be different elements of x's going to a y. And you're going to see a numeric example of what I'm talking about in a few moments. So this is the example what I was talking about. You see how you have all these different x's right here go to the same y? That is possible. That is what I'm talking about. So -4 and 4 can go to 16. That's fine. But however, if 16 was x, 16 cannot go to -4 and 4 if those 4's was on the y side. So yes, this is a function because all the x's are used and all the x's are different. And even it does not matter if they go to a same y. That's okay. That's cool. All right. Um, when you go to decimals, you see this function f of x. you're no longer going to see x and y no more. So f of x becomes your y. Now, earlier I told you that x go to y, and then the y go to x. That's in bijective, and when that's bijective, we call that the inverse. The inverse. Again, you must have notes of this. Alright? And again, for the inverse, like we said, if y goes to 2, and then you switch those points around, it is an inverse. And that is still a function. It's a bijective function. So we talked about what functions are. So now let's go ahead and talk about the characteristics. Yeah, the characteristics. In class, I gave you guys a small packet that talks about those graphs. And each graph has a characteristic that you would need to pay attention to. Now again, I have created a video from previous year that talks about each particular graph. So in this video, I'm not going to spend too much time talking about each particular graph because I already did that. I just want you to know the characteristics. The domain is all your x values on the graph. All your x values on the graph. Your range is all your y values of the graph. Domain is all your x values. Your range is all your y values, or your f of x values, because that is your y. So we know about even our symmetry. So this is even. This is even because if I put a negative 1 here, it becomes positive because when you think of even, two negatives make a positive. But if we look at the graph of symmetry, it is symmetric around the y-axis. But if I'm still talking about symmetry, if I think it's calling it odd, meaning that if I put a negative number in the function, it's still going to be a negative number because odd number of negatives is negative. So 3 negatives is negative, 5 negatives is negative. So here, I'm symmetric around the origin. This is odd because I'm symmetric around the origin. So that's for symmetry. Now, even odd functions, if it's even, that means the function either going to go up, up, or down, down. If it's an odd function, that means it's going to come from negative to positive, and vice versa. Asymptote. Say it with me. Asymptote is when the curve of a graph get close to a particular value but never touches or take forever to touch. It approaches the value but take forever to touch. Like for example, I gave in class, I say that I'm a okay dancer for to be Caribbean, so I may dance and dance and look good dancing. However, I don't dance like a black dude. You would still think, oh, that's a white dude dancing. But here's what you need to pay attention to, the details of the asymptote. The asymptote, you're going to have two types. You're going to have the horizontal or the vertical. So if it's horizontal, that means this is going to be your y. If you know the y value is going to be your range. Your y value is your range, and that is your horizontal asymptote. So in this case, my horizontal asymptote is going to be y equals b. And again, because it's horizontal, you use y. So my horizontal asymptote is y equals b. And my range is going to be b to infinity. Because that's what the value gets close to but don't touch. Alright? So let's talk about the vertical asymptote. The vertical asymptote is where it gets close to but doesn't touch it for the x-axis. So that means that my vertical asymptote, which is on the x-axis, is going to be x equals, it gets close, but it don't just cross C, or it takes forever to do it. So that means that my domain, because we consider x to be the domain, I'm not going to spell the rest of it. Domain, that means my domain is going to be negative infinity to C, because that's where it gets close to, and stop, because I'm dealing with my x-axis. If I said B, I mean C. So negative infinity gets to C. That is my asymptote. And now you know that the asymptote is affected by the domain and range. Your intercept crosses the x and y. Your slope is these graphs right here. So y'all know what slope is. But you know slope is only for the linear function. Linear function. Your vertex. Your vertex is going to be, of course, you know this shape is your quadratic function. And the vertex is going to be the tip of that vertex. I mean the tip of the parabola. Your axis is going to be h. This k is your max or min value. We know about period and amplitude. We know that it's all trig, so sine and cosine, and you're going to never be worried about tangent. So amplitude is the highest point. Period is how long does it take to get to one cycle. So if I start here at 0, well, my period is going to be 0. Right. Functions and characteristics. So I gave you a sheet like this earlier in the lesson. So again, I'm not going to go over these verbatim because there's a video out there that has all of that in detail. So here, the only thing that you need to worry about linear is that the domain doesn't matter. It's always going to be all real numbers, negative infinity or positive infinity, meaning all real numbers. Linear, your domain and range, it does not matter how you write your equation, your function. Rather, you're still going to have negative infinity and positive infinity, all real numbers always. And your inverse of a linear function is still going to be linear. Okay, so this next graph is a quadratic or square. This is the graph, has a vertex. It has a vertex. Its inverse is going to be a radical or square root function. So be sure you know that. So what we know about quadratics is that it doesn't matter how I write the function, the domain will always stay the same, but your range changes, but the inverse of it is always going to be square root no matter what. That's not going to change. So for the square root function, your domain and your range will always change. So here's a rule of thumb. If your domain has if your domain or range have a 0, that means that that's going to always change. Well, if your domain is negative infinity, positive infinity, or range is negative infinity, positive infinity, that's going to stay the same regardless. And of course, you guys know the symmetries, but here's what you need to know about symmetries. If they move, if they're not perfectly aligned, the symmetry is gone. But however, it's still going to be an even and odd function. It's just not going to have a symmetry. So pay close attention to that, all right? So again, looking through all the functions that we're going to talk about, if these typical functions are negative infinity, positive infinity, that means they do not stay the same. Each of these graphs that we are talking about are typical plane chain periods, meaning that these are your basic average looking graphs. So if I was to put this in decimals, like square root of x, guess what? It's going to look exactly, it's going to have these exact characteristics. Exactly. If I was to put an x squared, I'm going to have all these exact characteristics. Right? This is cube and cube root. These are typical cube and cube root functions. So they are inverses of each other, cube root. And a good way to remember this is, you know, the multiplicative inverse of 3 is going to be a cube root, which we know that cube root is x to the power of 1/3 in our previous lesson. So when we look at these two, it doesn't matter how I type the function, all the characteristics going to stay the same. Nothing will change. Cube and cube root, they're going to have the same exact characteristics always, no matter what. Rational. This is the weird one, the one that has the 2 and 1 graphs. Now, I already told you in class that because you got 2 graphs, you have to use that U shape to combine them together. So you're going to rewrite your domain from negative infinity, and because of this vertical asymptote, it get close to 0. And then it get close to 0 right here, but never touches, but keep going. So that's your vertical asymptote, which is your domain. Your range, it's going to be 0 because you go from negative infinity and get close to 0, but don't touch for one graph. And then the graph goes again from 0 to infinity, again get close to zero, approaches zero, but don't touch. Or it will, but it would take a long, long time. All right. So this rational function does not have an inverse. It's not like quadratic and square root and cube root. Those are perfect inverses of each other. Rational do not have an inverse. And so does absolute value. It does not. All right. These two, these are the functions that we're going to be spending most of our time on when we get back from Mardi Gras break. All right. So exponential and logarithmic deals with everything about life. From viruses, from money, from people. If you could think of it, it deals with these two functions deal with that. All right. So these two are inverses of each other, logarithmic and exponential. So if you look at it, you see how the exponential has a domain of all real numbers. And then if you look at your logarithmic, the range has all real numbers. But if you go back to exponential, that means your range is going to change depending on how you write your function. And neither of these have symmetry. Neither of these will have symmetry. And they're not going to be even or odd functions neither. All right. Sine and cosine functions, you know who they are. And those are the functions that have the period and amplitude. And that's all you're going to forevermore worry about. You're not really, well, you could talk about the domain, but do you know the domain is all real numbers? And you know the range of both of these are going to be -1 and +1. So your range is going to depend on your amplitude. Your range will depend on your amplitude. Your range will depend on your aptitude. All right. So your domain is going to be all real numbers regardless. So you don't have to worry about that at all. So that means the only thing that's going to change here is your range because of the amplitude. And of course, all functions symmetry changes. All functions symmetry changes. So if it's even, it may not be even no more. If it's odd, it may not be odd anymore. It may be neither. So keep those things in mind. Symmetry means that they are perfectly aligned. All right. So I gave y'all a worksheet. BA students in particular. A day I will give this to you when we see each other. But you will have this in form of Kahoot. So in terms of my worksheet, all I need for you to do is to look at the graph. Look at the graph and you're going to look for changes in the graph given to you. Remember your sheet that I gave you earlier are everyday typical functions. But the worksheet that I want you to do have the graph changes the characteristics. All I want you to do is to describe those changes. So here, we know from looking at the sheet that the domain, the ranges, negative infinity 0 unit 0 positive infinity. But the domain changes because I told you anything that has a 0 or a number at it, that's going to change. So therefore my domain and range change. However, we notice that those numbers you see in your domain, that negative 3, that's associated with your vertical asymptote. That too is your horizontal asymptote. Alright? Your x, y intercepts, you have them now. You usually don't have intercepts with rational functions. But because this is a rational function, and just look at the graph, it looks different. So one thing I do notice, despite all the changes I have spotted, the domain is just going to always start with a negative infinity and end at a positive infinity, but the numbers inside would change and everything else would change. And I mean the characteristics. So again, that's a video of me talk about the details of each function. So I'm going to end it here. Please review this video with detail, okay? And do those Kahoots and worksheets.